Hi everyone. So this is the second video about imaginary numbers, and more specifically, this is going to cover complex numbers and powers of I. Okay. Now I like to try to relate it to stuff that we've kind of seen before and worked before. We have done problems where we might get something that look like this. This is a polynomial. It has two terms. And the question might be, well, can we go any further with this? And the answer would be no, because they're not like terms. Okay, so it's something kind of similar. Complex numbers, rather than all have x's, right, or variables, okay, they all look like this: a plus or minus bi. And it's made up of two parts. A is the real part of that number, and B is what we call the imaginary part. Now that's because B has the I, so the I for imaginary, so therefore that's the imaginary part. Okay. Now we talked about imaginary numbers in the last video, about numbers that can't be plotted on a side-to-side number line. Well, 5 plus I can't be plotted on a side-to-side number line, but we can use each part to kind of get a new location. 5 would be the real piece, and technically it's one I, but we'd rarely write the one because the coefficient of one doesn't really change much. But it's the imaginary part, and I'll just shorthand that. So if we take a look, this 5, the number line, we're going to go right 5. So how can we represent 5 plus I visually? Is going right 5, and then up 1I. So we can't graph imaginary on a number line, but we can do it in this imaginary plane here. So this dot represents 5 plus 1I. Okay, so we eventually will add and subtract and multiply and all sorts of stuff with the complex numbers. But for today, we're just going to visually introduce them and kind of show what the heck it is. Okay, so next topic, quickly about this, okay, is this thing called powers of I. Now I'm just not being patient enough for my computer. So let's change the board. Okay. Now, just like we were doing with exponent properties or all that, we have to fully simplify. We can't have negative exponents as a final answer, so on and like that. That's the same with I. If we did a problem that ends in like any of those examples, we'd have to go further. Okay. Now, it comes in a pattern of 4. Okay. Now, if we take a look, every single possible answer, I'm going to hide this so I have a little bit more room, comes back to one of these 4 answers. Now, what I like about thinking about it in this way is that the answers for each of these, you don't really have to memorize. Anything to the 0 is 1. We know that. Anything to the 1 power is just the thing itself. Now, this piece, we know enough about I. I represents the square root of -1. If I square it and square it, because I'm talking I squared here, the square root and the square goes away, I'm left with I to the second is equal to -1. So that simplifies to -1. And this one is negative I. And the reason being is I to the third is really I squared and I1, because 2 and 1 give you 3. We just discovered that I to the second is -1, and I to the first is just I. So -1 times I is negative I. Now I'm going to get rid of some of this to kind of declutter. But what I mean is when we do a math problem and any power of I, okay, we're going to take that exponent and divide it by 4. Okay, so for example, let's do this. I to the 8th. We did some math problem, and that's the answer we got. So if I don't expect you to show all of this work out, okay, but this is just me demonstrating it. So 8 divided by 4 is 2. Now, it's 2 with no decimals and no remainder. The remainder is 0. So I to the 8th, if I simplify that, it's the same answer as I to the 0, which in our circle of 4 is 1. So my final answer is 1. I take the exponent and divide it by 4. The remainder is one of those 4 because it'll always be 0, 1, 2, or 3. And then we simplify its answer further. So for example, let's go I to the, sorry, not 12. Let's go I to the, let's say 10th. 10 divided by 4. 4 goes in twice, and so that's 8. Well, what's the difference between 8 to 10? The remainder is 2. So I to the 10th will give you the same answer as I squared, so the remainder goes to the exponent, and we look at our 4 answers in our circle. I squared is -1, and that's my final answer.